Hello. So these notes are titled operations of functions. In summary, just like you can add, subtract, multiply, and divide numbers, you can also add, subtract, multiply, and divide functions. So that's what we will be doing for these notes. So we are going to define f of x to be x squared plus 9. We're going to define g of x to be 3x plus 5, and then we're going to do these 5 things. We're going to find f plus g of x, f minus g of x, f times g of x, and lastly f divided by g of x. Oh wait, and sorry, number 5, f plus g of negative 4. In addition to doing those operations, we're also going to state the domain of our resulting function. So, we're going to go ahead and start off with number 1 and then make our way. So, for f plus g of x, you need to understand that this notation is equivalent to f of x plus g of x. So what it's asking you to do, it's asking you to take the function f and add it with the function of g. Now, f of x we know is defined to be x squared plus 9. And then we're going to add that with g of x, which is 3x plus 5. So in this situation that your two functions are just binomials, you kind of don't have to, I'm not going to be too picky about parentheses. However, like in subtraction, you're going to see in a second, parentheses are going to be super important. So if you wanted to, you really could add parentheses around these. But, you know, in addition, the situation of addition, they're not that important. So now once you have substituted into the two functions, you just combine like terms. So here, obviously, that 9 and this 5 can be combined to give you x squared plus 3x plus 14. And that is f plus g of x. All right, like I said, through subtraction, there's just one other step that you need to remember to do. So when it asks you to take f minus g of x, that's equivalent to f of x minus g of x. And then here, you do need to be a little bit more careful when you substitute into the function. So like we know, f of x is defined to be x squared plus 9. We're going to subtract that with g of x. But in this situation, you do need to write g of x in parentheses because this subtraction symbol needs to be, it's kind of like an invisible one there. You need to distribute out that negative to everything inside of the parentheses. So this will turn to x squared plus 9 minus 3x minus 5. You combine your like terms again with this and this to give you a resulting function of x squared minus 3x plus 4. And that is the new function of f minus g of x. All right, in addition to subtracting two functions, you can also multiply two functions, which is what number 3 has us do. And that would be something like f times g of x, which is going to be equal to f of x times g of x. A couple of things here. You do need to realize that sometimes they won't ask you like f times g of x. They might ask you g times f of x. They can flip around the letters. And all that means is that you take g of x and multiply it with f of x. So that just means that you do the g function first. In the case of multiplication, it's actually not going to affect your answer, but like in something like subtracting, it definitely will. So it's not always the f goes first. It's not always in general just a function defined by the letter f. There can be various letters there. So here, you would just, again, substitute in the two functions. On multiplication, also make sure that you're really picky on those parentheses. And then you have 3x plus 5. You know, you go through the motions. You do your distributing 4 times. I'm not going to do all the little steps of this, but this eventually equates out to 3x cubed plus 5x squared plus 27x plus 45. Okay, and then that's your new defined function. Step 4, or example number 4, is when you divide two functions. by definition, this is equivalent to taking f of x and dividing it by g of x. Now, this one, oh, by the way, I just realized right now, all these questions, I was also supposed to state the domain of the resulting function. The reason why I've kind of have forgotten to do that for 1 through 3 is because in essentially to consider the domain of a sum function or a product function, what you do is you just take the domain of f and you take the domain of g, and then you just restrict any values that need to be restricted, and then those will also be restrictions in the new function. But like if you look at both of these functions, originally from the start, they both have a domain of all real numbers. Remember, you should always assume, or you can always assume that the domain of a function is all real numbers unless it has a fraction. So it has a denominator, which you need to exclude the values that give it 0, or it has a square root, and you need to exclude the values that give you a negative under the square root. So since neither one of these original functions have that, the domain of each one of them are all real numbers. So by default, the domain of the resulting functions also are all real numbers. So this one, the domain would be all real numbers. This one, the domain would be all real numbers. This one, the domain would also be all real numbers. It's not until something like division where you will get a different type of domain. Or like I said, if originally these functions didn't have the domain of all real numbers. So in number 4, what you'll be doing here is you're going to substitute in f of x, which we already know is x squared plus 9. Then you're going to substitute in g of x, which is 3x plus 5. So this is your resulting function. However, for this one, now you have created a function which has a domain that you need to restrict. Because your resulting function is a fraction, you need to exclude the values in the denominator that will make this equal to 0, because remember, this cannot equal 0. So in this case, you can set 3x plus 5 equal to 0 to figure out which value would give you that 0. So once you do a little bit of solving here, you end up getting that x cannot equal negative 5 over 3. If you substitute in negative 5 over 3 for x, you will get a domain, an undefined domain. So for this one, your domain would be x such that x cannot equal negative 5 over 3. Okay. That's 1 through 4. Let's do the last one, number 5. So number 5 it looks a little bit different because they want you to find f plus g of negative 4. Now, all that changes is they now give you an input to substitute in for x rather than just the variable x. So there's a couple ways that you can do this. As we know, f plus g of negative 4 is going to be defined as f of negative 4 plus g of negative 4. Now, there's a couple ways you could do this. You can first find what f of negative 4 is, and then find what g of negative 4 is, and then add those two answers up. Or you can just find the general one, which we already have right here at f plus g of x being x squared plus 3x plus 14, and then just substitute in for x, our input that they give us. So I'll do it both ways to kind of show you that. So if I wanted to do it the first way, then I would take the function f and substitute a negative 4 into it. So that would give me negative 4 squared plus 9, which would simplify down to, what is that? 16 plus 9, which is 25. And then I would find g of negative 4, which would,
Gabriel Amador, report to the main office. Gabriel Amador, report to the main office.
Okay, I would find g of negative 4, which would be 3 times negative 4 plus 5, and then that equates obviously to, what is that, negative 12 plus 5, which simplifies down to negative 7. And then now with these two values, we can take 25 and add it with negative 7 to give us 18. So f plus g of negative 4 would be equal to 18. Now that's one way that you can do this. Or like I said, you can first just find what f plus g of x is, which we already know. F plus g of x is equal to, we did it up here, x squared plus 3x plus 14. So now we can just substitute in the value of x that they want us to substitute in, which would be negative 4 squared plus 3 times negative 4 plus 14. You do some algebra, this would give you 16 minus 12 plus 14, which gives you 4 plus 14, which also then gives you 18. So either one, you'll notice that they both equate out to 18. So it's the same process, but like I said, your answer ends up being a number because they actually give you an input to substitute into the function. All right, so knowing how to add, subtract, and multiply, and divide functions is going to be important for the first part of your classwork. It'll ask you to sometimes do it with respect to x. They will also ask you to evaluate it at a certain input. I think the only reason why these might get tricky are if your original functions are not nice linear or quadratics. Sometimes if they start you off with a function that has a fraction or a square root in it, this combining of like terms and things gets a little bit more involved. So make sure that you ask if you have any questions on those. Okay.